Hello and welcome back. Today is part 10 of building an AI computer improviser from scratch in Max. What we're going to be doing today is building out the utility of the labels. So the Flucoma label sets are represented in this plotter with color. So if you recall, for these objects, that number 8 at the end, that, I don't know, fourth argument, is how many labels we want. So I've got 8 different labels, and they're sorted by fluid.kmeans, which does sorts data by clusters. So if I play back the samples of the different onset slices of this guitar piece I recorded, you can hear that the different colors that correspond to different labels also have sort of noticeable different timbre qualities. So harmonics. Yeah, so you can hear that different labels have different timbre qualities. So we're going to take advantage of those labels and build a Markov chain that will use sort of what label comes after the next. That we will combine with the rhythmic Markov chain that we already made in an earlier video. So the first step is to get the label callback functional, by which I essentially mean make it so that we can ask it for to play back a sample from according to label. So any playback any sample that has a 8th label, any sample that has a 1st label, and choose randomly within those clusters. Great. So let me just draw up something here on my second monitor so I can have myself organized. Okay, great. Okay, so this is already done a little bit with these kmeans labels and label sort subpatchers here. If I open that up, we see that we have 1, 2, 3, 4, 5, 6, 7, 8 different lists here, and so these correspond with the slices. So the 0th label are slices 5, 6, 7, 8, etc., etc. The 1st label, 2nd label, 3rd label, 4th label, etc., etc. So in order to store this list and be able to call back from it randomly, we're going to build a little subpatcher here. So let's go P, and we'll call it, we're going to use earn, so label earn, we can call it. And so what we want is an inlet. We'll want an earn. So yeah, it generates random numbers without duplicates. We will want a second inlet for our data to come in by. And instead of having this all out like this, I think we will take that into here. So we can leave the prepend append outside though, because we'll want to get at this list object without having that in the way. So we'll just do it like that. Okay, great. So one way we can do this is we can use zl.length and send it this list, and it will give the length of the list to the earn. And so it won't store all these numbers, but it will store how many possible numbers there are. And I'm going to have a clear. So if all numbers in the range have been chosen, I will clear the earn so that we can just keep cycling through if need be. Now we'll want to use zl.nth, and this will store a list, and then you can extract the nth number from the list. So we'll store our list in the zl.nth. And then we will, what is this one? Position in the list to extract, okay. Right, so we'll give it the integer and then bang it out. So we'll want a trigger bang integer. And because zl.nth, I believe works from, not from the 0th, but from 1. But earn works from 0th, we want a +1 there. So trigger bang integer. So we will store the integer in the right inlet and then bang it out with, extract it with the left inlet. And then let's make sure that this is working. And so every time we bang the earn, it should send out a random one of these numbers. Great. So now we'll want to send it to this object, because when we give the make note a slice number, it plays it. So if we go into here, oops. Now I have this issue sometimes where in subpatchers, when you lock it, it doesn't actually, the hashtag 1 doesn't go to the first argument. So I'm just going to, I'm not sure if there's an actual reason for that I can fix, but in any case, let's see if I can get it to work if I close it and open it again. Where was I? Sorry, label sort. No, it's the same problem there. Okay, so I have a workaround that sometimes works. Again, if anyone watching this knows about that bug and knows how to avoid it, if it's maybe a user error. Okay, well anyway, it works in there. So I'll go ahead and, though we want to send it, of course, to our make note object. So if we put a bang in the left inlet here, it should work. Right, so all the slices, random permutations of all the slices, all the 0th slices. Great. So now we'll need it to work and store that upon analysis. So we can get rid of all this. We will want to use this, have this set argument first go into the message box. And then we will want, and we will also want prepend, append to go into the same one. And then for now, we'll just want to be able to test it with this bang. We'll have to add some communication there. So I'm going to actually, I think for this particular group of sounds, I think 6 is maybe more appropriate. Oh, I hope I saved that before I close it. Oh, I did, good. I'm going to redo the analysis. This will take 30 seconds or something because it is 10 minutes of audio. Okay, did that do it? Yeah. Good, so let's go and see if, so it should just work now if I bang this. Oh, it didn't. Okay, so what did I do wrong? Ah, I know what I did wrong. I did not bang out the list. So if I bang that out, okay. So for that, we can take the flag from the Uzi that is in, so I'll go in the same one because that'll bang out the message. And if I go back, if I go to here, I want the bang from the, wait. Yeah, I want the flag for when, is it that? Done banging, yes, because I'm giving the size of, yeah, so when it's done sending all the bangs out of the Uzi, or all the indexes out of the Uzi, it can then load it in. So to simplify that, I think what I'll do is put this all into one thing here. So before I delete it there, bring that in here. So I have the middle one going to, it's a bit of a mess. The middle one is going to the left. The left one is going to the middle. And there's nothing going to the third one, right? Because I just added that. And that's not going, okay, so it's just those two, good. So I'll get rid of that there. Go back into here, and I no longer need these outlets. So actually sort of simplifies things a little bit, but I do need this flag from the Uzi so that it will then actually send this to the ZL length and nth objects after analysis. So again, let's test it. So redoing the analysis, and great. So all I need to do from here is duplicate it for each of the different ones. So I have here 20 different possible things, so up to 20 labels. I found that with the exception of when I was trying to extract different phonemes and cluster those, where I wanted to have like 20 or 30 from trying to organize phonemes in speech, I've never found that musically more than 20 labels made sense for me. Though, maybe you will find that, in which case you can add higher numbers there. And there's probably a more efficient way to program this as well that is more malleable as well, I'm sure, but this is how I've done it. So if I just copy this out, and so I'll for now, just to test it, I'll just do it with 6 because we have only 6 labels. So I'll probably fast forward this part of the video. So I'll just do this quickly. Great, so that's the 6 labels that we're just going to use for today, and I'll expand it out to be all 19 later, or all 20 later on. So now we're going to want to be able to communicate with these, just be able to say, I want a random 0th label sample, I want a random 5th label sample. So for that, we can just do a receive. Let's say label trigger, I guess. Yeah, mfcc slice label trigger, and then this can go to a select, and then we'll want to have also the 20 as sort of the max number, might as well, since that's what I'm doing for the analysis. There. So for today, it only needs to go from 0 through 5. So 0, 1, 2, 3, 4, 5. Okay, so in order for these to actually get data in their earn and their ZL objects, we'll need to redo the analysis. Great, so now if we, even here in the main page, so let me just get this open again. So if we go to the, yeah, so it is mfcc slices underscore label trigger, send mfcc slices underscore label trigger. And now if we send this a 4 or a 5, 2, 6 won't work. It has to be 0 through 5 there for the 6 different labels. Okay, great. So we have our trigger there. And so now if we go into the Markov rhythms, we can, instead of triggering a we need to train the Markov. Okay, we will need that in there eventually. But before that, we will need to train our an ml.markov object, again, building out this area. So let's make another subpatcher here. We'll call it subpatcher Markov. And we will need and inlet here, and we will create our ML. So this is from the ML dot star library by Benjamin D. Smith, which is available in the package manager. Great set of objects. We will want to be able to train it dynamically, so we'll do @dynamic1, and we'll do @order. We'll do third order. And so we'll send it our data that it adds to its model into the left inlet. We will have the second inlet be a build, message, which we'll probably use this flag to do. And before anything starts, we will want to, when we do a new analysis, we will want to clear it first. So actually, no, we don't want to clear and build there. We will want a third inlet to clear it. So I'll just add a trigger bang bang at the very entrance there. That will clear. Our label set, our label information comes from the out inlet 2 here. So we'll grab that, and that will be what we train our ml.markov with. And then the middle is to build. So once everything has been extracted using the Uzi, we will build it like so. Okay, great. So let's redo the analysis and then jump back over here. Okay, great. So now let's see if I had it all correct. So now if I bang this out, yep. Right, so we're getting our numbers for the different labels. And you see there's a lot of repetition, which makes sense for the labels. Now all we need to do is to send this. Well, I have a feeling we're going to have the same issue with the argument call. So let's go ahead and have an outlet, and then we're sending it to our make note. So let's take it from there. Oops. Good. And there. So now if I bang out this, cool. Great. So so we're going to need to be able to query this, of course. So let's do a receive object. Markov label. And that can go right in there. Let's clean this up. And okay, so now that should be all we need. And so we'll go into our Markov rhythms here. And we'll send, and then of course we need the actual name of it here. So this is send mfcc slices Markov label. Let's see if this works. Great. So instead of triggering a random sample here, we are going to trigger this Markov chain. So now we have the rhythm as well as the playback going to the Markov chain. Oh, you know what? I just realized a mistake. Of course, we're not sending that number. That's why we're hearing the same slices over and over. It was plain slices 0 through 5. We want to send it to this here. We want to send our Markov chain to that. Oh, sorry. Send. Okay. That should work properly now. I should have clued into that right away. just to test it. Great. So now this is our Markov chain for rhythm that we've already made. And to turn it on and off, it's just this switch right here. Great. So we have a basic musical behavior here. It's working reasonably well. I think there's some awkwardness when the length of the sample that it plays back is much shorter than the wait time between. So there are different ways we can deal with that. One would be to, instead of only playing full slices with a make note, we could have a sort of a second make note object that would force a duration and have that duration correspond with the rhythm that comes out of the Markov object. We could also just be kind of more brutal with it by adding an extension amount. So, for example, I think that's what I'll do for right now. So we do mfcc slices extension, and I will take 1,000 away from there, assuming that all the slices are about a second long, but otherwise add that as an extension to the one that's played. So for this, let's go trigger int like so, and just sanity check there. That's cool, because this also shortens ones. It also shortens samples when the rhythm is much faster. Okay, it has an adverse effect. All right, it has for me, it has an unforeseen effect when they're very, very short. So I would say, okay, one way we could do this is greater than 1,000. And then gate is greater than 1,000. Or no, I won't do it the other way. If it's less than 1,000, hold on. If it's less than 1,000, it'll send a, okay, so, okay, cool. So plus 1. So if it's less than 1,000, then hold on, we want another trigger. We want another int here. So trigger int. So first, is it less than 1,000? That will open up either the yeah, first to second gate, then the int goes through here. If it is less than 1000, then just want a 0, have the extension be nothing. If it's greater than 1000, I want the extension to be that. And so let me just add a print object. This is kind of a hacky way of doing it, admittedly, but let's see musically if it works. Okay, so what is my mistake here? Why do I not get a 2? Oh. I want a greater than 1000, don't I? Yeah. I think I want to extend them all a little bit. Okay, so that's now, musically that's working for me now. It is kind of now creating a mixed up Markov chain sounding version of the original piece, which is exactly what we're going for here. So I'd say this is an interesting musical behavior now that we may want to make more robust by varying the dynamics somewhat. Definitely having the pan move around. In fact, why don't we go ahead and do that one? We could have it just sort of go I think I'm using the drunk object correctly here. Let me just double check that. Yeah, that's what I wanted. So it'll sort of move around randomly. Great. So we'll have the pan somewhat randomized as well, but not just jumping all over the place, but sort of gently moving around the stereo field. Cool. Okay. Yeah, I like that. Great. So we now have our first Markov musical behavior, and we will be able to we could have a different Markov musical behavior for the different all the different analysis objects quite easily by just changing a few of the object names here. So that is our second musical behavior that we've made in this patch. I think for the next video, what I might do is pre-make a bunch of behaviors and then just show them, just go through a bunch of them. And then after that, it will be starting to mess around with how to combine the musical behaviors and how to have the musical behaviors shift dynamically in reaction to the live input. So yeah, something to think about, but sort of basic things like if the live performer who's playing with the patch is silent for a few seconds, then after which point, if they do make a sound, a new behavior will appear, or there'll be like a 40% chance of a new behavior to appear. Basically thinking about how I might react as an improviser myself, but also keeping in mind the particular strengths and weaknesses of how a computer makes music versus how a human makes music. Okay, so that's it for today, and thank you.